Hi everybody, welcome to the DeWet Classroom. In this video we are working from the C2 Core Maths textbook by Pearson, and we're busy working from chapter 1 exercise 1b questions 3a and b. Okay, we've got a polynomial here with 1, 2, 3, 4, 5 terms, and we need to divide it by that x plus 2. So basically we need to prove or see whether the x plus 2 is indeed a factor of this polynomial or not. Okay, so we are going to rewrite it in the correct form. Please note that it needs to go from 4, 3, 2, 1, and there's x to the power of 0, which is 1. If one term is missing, then you have to insert something, insert a 0x and the power you are missing. But it's not necessary because all the powers are present. So I'm just rewriting it in this form so that we can actually start our long division. And then we're going to start with our first term by saying x to the power of 4 divided by x is x to the power of 3. Because remember, your rules of indices say when you divide, you actually subtract the indice. X to the power of 3 times x is x to the power of 4. And x to the power of 3 times 2 is 2x to the power of 3. We need to subtract them from one another now, but before we can subtract them, we need to change the sign. A lot of students forget to change the sign, especially the second one. X to the power of 4 minus x to the power of 4 is 0. 5x cubed minus 2x cubed is 3x cubed. Then we bring down the plus 2x squared. We start the process again. 3x cubed divided by x will give us 3x squared. 3x squared times x is 3x cubed. 3x squared times 2 is plus 6x squared. Right, so we need to subtract them. So we change the signs, and 3x to the power of 3 minus 3x to the power of 3 is 0. 2x squared minus 6x squared is minus 4x squared. Then we bring down the minus 7x. We start the process again. Minus 4x squared divided by x is minus 4x. Minus 4x times x is minus 4x squared. And minus 4x times 2 is minus 8x. We need to subtract, so we change the signs. Minus 4x squared plus 4x squared is 0. Minus 7x plus 8x is just x or 1x. And then we bring down the plus 2. X divided by x is 1. 1 times x is x. 1 times 2 is 2. We need to subtract them from one another, so we change the signs. X minus x is 0. 2 minus 2 is 0. So we can now confidently say that x plus 2 is indeed a factor of this polynomial because the remainder is 0, and our answer here, the x cubed plus 3x squared minus 4x plus 1, this is our answer, also known as the quotient. When you multiply the quotient with the factor, you should get back to the polynomial. Okay, number B. We rewrite it in long division form, so we get x to the power of 4 plus 11x cubed plus 25x squared minus 29x minus 20. All divided by x plus 5. Okay, we're going to start with x to the power of 4 divided by x is x to the power of 3. X cubed times x is x to the power of 4. X cubed times 5 is plus 5x cubed. Right, we subtract them from one another, so we need to change the signs. And then we've got x to the power of 4 minus x to the power of 4 is 0. 11x to the power of 3 minus 5x to the power of 3 gives you 6x to the power of 3. Then we bring down the plus 25x squared. We start the process again. 6x cubed divided by x is plus 6x squared. 6x squared times x is 6x to the power of 3. 6x squared times 5 is 30x squared. We need to subtract, so first of all we change the signs in front. So 6x cubed minus 6x cubed is 0. 25x squared minus 30x squared is minus 5x squared. We bring down our next step, minus 29x. So then we start the process again. Minus 5x squared divided by x is minus 5x. Minus 5x times x is minus 5x squared. Minus 5x times 5 is minus 25x. We're going to subtract this from one another, so we change the signs. Minus 5x squared plus 5x squared is 0. Minus 29x plus 25x gives us minus 4x. We lastly bring down the minus 20. Minus 4x divided by x is minus 4. Minus 4 times x, minus 4x. Minus 4 times 5 is minus 20. We need to subtract them from one another, so we change the signs. Minus 4x plus 4x is 0. Minus 20 plus 20 is also 0. So we know that x plus 5 is a factor of the polynomial, and that is in fact our answer, also known as the quotient. This concludes the video for exercise 1b, question 3, A and B.